Okay, so let's begin the installer training. Okay, we're going to go, what we're going to do is you've now watched the video, which gives you a lot of technical information that you might not be familiar with. Okay, and what we're going to attempt to do is we're going to unpack that first, and then we're going to look at the safe handling when you're working with R32. So we're hopefully going to start building up on your confidence and on your knowledge, because knowledge is important when you're working with something. Yeah, so we're going to break it into 3 sections. Section 1 is why we are changing to R32. Okay, then we're going to look at the standards, and then we're going to look at working with R32. So why change to R32? And here we're going to be looking at the HFC phase down from 2015 to 2030, the refrigerant properties, and R32 in the market today. Okay, right. So let's have a look. Refrigerants that are going to be banned by the year 2030. If you look at that list over there, 143A, and then R404A, and you can see we give a blend there, and then R125, which is going to be important to this morning's discussion because you guys have probably been working around it if you didn't know already. Okay, phase down refrigerants. These are refrigerants where the quantity of them in the market is going to be phased down by the year 2030. And in there you see 134A, 410A, which is a common air conditioning refrigerant and also used in refrigeration as well, 407C, and even the R32 that we're talking about today is going to be phased down in this period. And this is mainly because the reason why we're going over to the R32, we'll discuss this, is if you look down the right-hand side of this column here, can you see the global warming potential? Okay, now when we first started phasing out refrigerants, the very first thing that was targeted, okay, was ozone depleting refrigerants. Those are off the market, okay, largely today. And so now the focus is now going to global warming potential to target those. And as you can see here, okay, when we look at this bottom list, the global warming potential figures are now single digits, okay? And these are the new refrigerants that we're going to see entering the market over the next couple of years. In the meantime, R32 has been chosen as the refrigerant while these become available, and also some of the technical issues of working with CO2 and propane and ammonia are well known within the industry. Okay, so you can just keep those in mind. I'm just going to change something over here quickly. Okay, all right. Okay, so what is R32? Okay, well, it's a single component HFC, and it's known as difluoromethane, chemical CH2F2. Okay, it's already been used, and you may not know this, but you've been in contact with it since you've been working with 410A. It is 50% of 410A is R32, and the other 50% is 125. Okay, and the component that has the high efficiency and thermodynamic process that gives 410A its ability to be a very good refrigerant is the R32. Okay, and the 125 was added as a flame retardant. Okay, because they've introduced this refrigerant into the market at a time where the skill set was of concern that technicians may not be able to work with a slightly flammable refrigerant. And so we've been working with it for a couple of years, and now the game is changing. We want to upskill the guys and get them used to working with the refrigerant. Okay. Right, so if we look at the 50-50 R32 and 125 mixture, and we look at it as a seesaw, we can see that the R32 has a lower global warming potential number of 675, while the R125 has a global warming potential of 3,500. Okay, we also know that it's also the predominant component that gives 410 its very good ability as a refrigerant. Okay, combined together, okay, these two give 410 a global warming potential number of 2,088 over there. Okay, so what does this mean? Okay, basically, we're looking over here now at comparisons of the CO2 equivalent, okay, of each of these refrigerants. And we can see that the global warming potential of R32 is up to a third lower, okay, a third of the amount of R410A. It has a better refrigeration effect, and in conjunction with this, the charge on units will generally be 30% less than the amount of refrigerant that went into a 410A system. Okay, overall, its global warming times its quantity gives it a quarter of the environmental impact that R410A has. Okay. If we were to have a charge of 10 kilograms, okay, and this was released into the environment, okay, each of these refrigerants would have a total CO2 equivalent, okay, or tons of CO2 equivalent for that 10 kg charge. And we can see R23, as in a comparison over here, has got a very, very high number. 410A at the bottom of the list down here, okay, is not too bad at 20.88, but R32 by comparison is much better, okay, only 6.75 tons of CO2 equivalent. Okay, should a 10 kg charge be released into the atmosphere? This is very important because global warming is real, okay, and we've seen the effects of it in the change of weather and in our climate that's getting warmer, and we do need to start targeting these things, okay, and their effect as well that they have with refrigeration plants that are drawing electricity means that we want plants that draw less electricity so we don't have to emit carbon through our power stations and things like that. Okay, so there those two are as a comparison. Okay, so example of CO2 equivalence. Let's have a look at this. A 410A unit, okay, 3 kilowatt split system, which is a common size split system, okay, would generally with 410 would have a 1 kg charge, okay, and would have a 2.088 tons of CO2 equivalent. How does that compare to the R32 plant? Okay, we see there that the charge goes down to 700 grams, okay, and its effect of 0.4725 tons of CO2 equivalent. You can see that's considerably less than 410A. So it's a very, very good reason why we should be changing over to R32. So it's 0.3 kgs less and 71% difference in the tons of CO2 equivalent. All right, so we've finished the first section, so we've gone through that quite quickly. Let's have a look at the standards, okay, and unpack some of the technical terms that you saw in the video. All right, so we've been discussing in R32 is in terms of the ASHRAE 34 and draft ISO 817, R32 is a slightly flammable gas. And you're going to ask yourself, what is slightly flammable? Okay, something in my mind was it's either going to burn or it doesn't. Why would something be slightly? So let's unpack that. Slightly flammable gases, as far as ASHRAE goes, are classed as class 2L. Okay, they have to have a burning velocity of less than or equal to 10 centimeters per second. Don't worry about that too much now. I'm going to show you another video and you're going to understand that soon. Okay, and the other refrigerants that are in class 2L are ammonia. Okay, and then of course there's your R32. Class 1 are non-flammable, there's 410A and CO2, low flammable 152A, and then of course our highly flammable are our R290 and 600A, which are very common in small refrigeration units these days. Okay, so again in the table, how do we now look at this from toxicity? So we've had a look at the flammability from high, low, and non-flammable. Then we look at toxicity, very important component of refrigerant, because if the refrigerant comes into contact with people or with food products or animals, we don't want it to be of effect to them as much as possible. So 410A and R22 are non-flammable. They are therefore as far as A1. Okay. Propane and isobutane are highly flammable, but they are also non-toxic, so they are class A3. Okay, R32 we said was a low flammable, so it is classed A2L. Okay, and ammonia, low flammable but highly toxic, and you see there that's given the class B2L. So that's how the classifications of the refrigerants are set up. Okay. The other thing that you would have heard in the video was the gentleman talking about lower and upper flammable limits, okay? And this is not too difficult to understand. If ever you've worked on a motor car with a carburetor, you'll understand some of the terms. Yeah, so first of all, for the technician, we need to understand what is going to happen with the refrigerant, okay? The density of a flammable gas is very important to know. And in the case of R32, it is more dense than air, meaning that when it leaks out, it is going to go to the lowest levels. So these are very important things to know, because if it was going to be in a condition where it could ignite, the ignition would normally take place in the lower levels. And also, again, if you're working in basements, you'd also need to realize that as per other refrigerants, that is where the refrigerant is going to rest. And it could be a problem for people that are working in the area in terms of asphyxiation, lack of oxygen when they're breathing, okay, which we all know is not good for humans. Okay, so if we look at the density of the refrigerants, R32 is 2.15, isobutane is pretty much the same, and 410A was 1.24. So all of these gases, okay, they are all more dense than air. And acetylene over here, a very, very common gas that we work around, not a refrigerant, but we use it for brazing, 0.9. All right, so let's unpack the lower and upper flammable limits. Okay, very important that on the left-hand side of the graph, we are looking at 100% air, 0% gas. And on the right-hand side here, we have 0% air, 100% gas. Okay. All right, the lower flammable limit, just excuse my hits. We have a lower flammable limit, okay, and we have an upper flammable limit. Now what that means is that anytime the mixture lies between these two lines, okay, we have a risk of it igniting, okay, if a flammable source or ignition source is applied to it. All right, so let's have a look at this over here. On the left-hand side, we've got too lean, and on the right-hand side, we're talking about too rich. And obviously, if you worked on a motor car with a carburetor, you'll always remember to set it up. If the fuel mixture was too lean or too rich, you would never get the engine to turn over, okay, or for the fuel to combust in the engine, okay. So it's not a difficult term to get your heads around. Okay, so every flammable gas needs oxygen to burn, but how much oxygen depends on the gas. And a flammable gas can only burn between the lower and upper flammable limits. Okay, so as we said, it had to be between those two lines. Okay, with R32, only a mixture of 14 to 31% of R32 can burn. All right, now you think that's quite difficult to picture. So let's have a look at some other refrigerants. In a bar graph, okay, that's effectively the area where you would have the possibility of the refrigerant burning, provided it had an ignition source. Let's have a look at these over here, okay. Isobutane, okay, you'll see there its ignition source between 1.8 and 8.4%, very much to the left of the graph, okay. Natural gas, also in that region. Ammonia, very, very similar to R32. 410A doesn't burn, because it has the fire retardant R125 in it. And of course, here's the gas that you've been carrying every single day of your working lives as an air conditioning technician, acetylene. Look at this on the bar graph, 2.3 to 80%. By far a much more dangerous flammable gas to be carrying. So obviously over the years, you've been taught safety methods, and you've practiced those safety methods when you've transported and worked with this. Okay, so these are hopefully habits, okay, that we're now going to transfer to R32. All right, okay. Another way of having to picture this is everybody wants to know, how does this work for an air conditioner? All right, so what sort of charge would we need to have leak out from an air conditioner into space for there to be a problem? So let's take some spaces over here, and let's have a look. If we had a 5 square meter room, which is tiny, okay, you've got about 5 square meters is tiny with a 1.8 meter ceiling, okay, in order to get to the mixture where it would be dangerous, okay, where it could ignite, you would need to have 2.3 kgs of gas. Now think back to that image just now where we looked at the unit. A 3 kilowatt system only has 700 grams of gas, okay, so you can see that there's you're never going to put a 3 kilowatt system in here. In fact, it's going to be, the 700 grams will never ever get dangerous. If we start taking this up and we start looking at, for instance, 25 square meters, okay, that would be the type of area that we might be looking at putting a 3.5 kilowatt unit into, okay, in that area. That would be 5.1 kgs. 5.1 kgs is equivalent to what you would find in a 14 kilowatt system. Okay, so you can see that from the effect of the square meterage, when the units are sized, they're never going to be a problem if the gas leaks into that area. Okay, so we should never ever reach the area between the lower and upper flammable limits. So as I said, technicians generally will always find themselves on the left-hand side of the graph, okay, where the mixture is too lean for it to burn. Okay, a fire will be triggered by flammable refrigerant if 3 conditions are met. Okay, so this is going back to some basic firefighting things that you may have gone through if you've done a firefighting course. Okay, 3 things are required. They're called the fire triangle. And in order to create a fire, we need a fuel. In this case, our fuel will be the refrigerant R32. If there's a problem, we will need the presence of oxygen, okay, out of the air, and we will need an ignition source. Okay, remove any one of these from the triangle, and you cannot have a fire. Okay, or control any one of those 3 to a safe limit. You cannot have a fire. All right, so if we're looking at the density, okay, and the lower flammable limit and the ignition source and the amount of refrigerant, slowly leak the gas test into a 1 cubic meter box. This is an experiment that they've done, and they add an ignition source. When I watch, okay, so these videos are now going to show you the effect of certain refrigerants when in contact with an ignition source. Okay, the first one we're going to be looking at, okay, is propane, and it's spark, and it's only 30 grams. Watch the explosion. Okay, if you watch it in slow motion, you'll see it even blew the window out. Okay, so that's propane. The next experiment is R32, 300 grams. No ignition occurs. Okay, we're going to reduce that down. Okay, we'll increase it to 320 grams, sorry. And now you can see fireballs starting, okay, but nothing, okay, close to the intensity that the propane exploded with. Okay, so that's very important to keep in mind, because you remember back in the beginning, you would have heard that the term, the velocity of the refrigerant when it ignites is very important in determining what class of refrigerant it is. So the ignition velocity on there. Okay, and here, if we look at an aerial view of that refrigerant, we can see it's quite tame. It's only about 6.7 centimeters per second. Okay, that is R32. As opposed to our butane, you can see the intensity and speed of that at 46.6 centimeters per second. All right. Right, so we're into the part of the course now where we want to talk about working with R32. So how do we take this knowledge that we've gathered in parts 1 and 2, and how do we apply it in the field when we are working? Okay, so as we discussed, R32 is HFC refrigerant, global warming potential number 675. It has a boiling temperature, okay, of -51.7, slightly lower than 410A, okay, and quite a bit lower than R22. So just remember, when working with refrigerants, do not allow them to come into contact with your skin when they're in liquid form. They will burn you, and at those temperatures, that is a safety point. But again, you've been working with refrigerants already that operate at very, very low boiling temperatures. Same safety things: wear gloves, wear goggles. Okay. The oil of the refrigerant is identical to 410A, okay, but both of them different to R22. R22 is a mineral oil. Both of these refrigerants use synthetic ether oils. Okay, so also very important to remember, okay, as you start working around the units. How does it look in terms of pressure temperature? Well, the blue line at the bottom here is the pressure temperature curve for R22, and it's done in absolute pressure, so we'll see at 0 we are just under 5.5 megapascals, okay, and you'll see that the R32 and R410 are very, very close together. So in the evaporator section, the pressures will tend to track very close. It's only when we get into the condensing area that the two lines start to split apart. Okay, so we'll see that R32 will have a slightly higher pressure than 410A, and also of consideration is that it will have a higher discharge temperature. Okay, and R32 does have a higher discharge temperature, and this must be kept in mind when working with it. If you're a technician who monitors discharge temperature, which is a very important item to monitor, you'll notice that if you touch the discharge pipe, it will burn you very, very quickly. Okay, so you need to keep those things in mind when working around R32. Okay, storage of refrigerant vessels. Okay, so there's two ways that we generally store refrigerant vessels. They are either in our vans as we work, okay, or they are stored in our places of work, in our workshops. So what are the things that we need to know about storing the refrigerant? Calculation of ventilation for transportation in a small commercial vehicle. Okay, so if you've got this R32 in your van, you need to know how much ventilation is required for that while you are driving your van. So if we take 1.2 kgs, which will give us 0.585 meters cubed of pure gas, okay, and we aim for a low flammable limit of 14%, okay, and we take that amount of gas at 0.4585 meters cubed pure gas, that'll make 4.2 meters cubed mixture theoretically perfect. If we add a safety factor to that of 4, okay, we're looking at 12.6 meters cubed of fresh air required to be safe, okay, should that refrigerant leak out, okay, in the van. So watch point in there. So let's just go back there. So that's what you would need to be going through the van. So what do we need to know? The calculation for the ventilation of transportation. R32 is heavier than air, so the ventilation must sweep the floor area of the van. Okay, so you actually want airflow over the bottom of the van. Okay, you need permanent ventilation when driving, so that you should always have ventilation in the areas where you're storing gases, and that includes acetylene. Okay, so this is something that should have been practiced all along. Okay, no smoking. Sorry guys, you should never be smoking in your van if you consider that you've got acetylene close by. So you shouldn't be smoking when R32 is there from a safety point of view. And as this image shows, the ventilation should be coming in through the top or through a window, and then needs to be able to vent out through the bottom to make sure that it sweeps any flammable gases, R32 or acetylene, that might be leaking out inside your van. Okay, and installers should already take the same precaution for transporting acetylene for brazing. Okay, storage of refrigerant vessels. R32 is a high pressure gas, just like 410A, 407 and 134A. It's supplied in a highly safe pressure vessel, so you need to protect the pressure vessels from dropping, being knocked down, impacts and rolling. Right, so the same safety standards when you handle those. R32 is, according to the ASHO 334 and ISO 817, the slightly flammable gas. Likewise, other high pressure gases, R32 should be stored in accordance with the safety standards, with standards established by laws and regulations, or the material safety data sheets. These data sheets are available from the suppliers of the refrigerant, okay, but I will be sending you guys a data sheet from one of the suppliers as well. Okay, refrigerant vessels need to be stored in a cool, dark place that is well ventilated, with a temperature lower than 40 degrees Celsius, and implementation of fall prevention devices needs to be put in place. Fall prevention, basically cylinders need to be chained, okay, to a solid structure so they cannot fall over. Okay, Exact instructions for storing R32 in a safe way should be obtained from the refrigerant supplier. Okay, it's always best to go back to the supplier of the refrigerant and get their data sheets and safety standards as well. Characteristics of the 410A cylinders. Okay, so how do you identify them? You'll notice that the cylinder has a red shoulder. It has a left-hand thread. Okay, so remember, pretty much like your LP gas and acetylene, any gas that is flammable, the thread is changed to left hand, so you cannot interchange devices that go on there. Okay, minimum test pressure for that vessel for R32 is 48 bar, and an adaptive piece is required to change it from left to right hand thread. Okay, and the right hand thread that you generally use is your 1/4 inch flare that you put your gauges on to. Okay, R32 is still classified as an A2L refrigerant. Okay, right. This is a general work area that's being set up to kind of reflect what sort of equipment you would need while working. Okay, and the F-gas regulation for refrigerants, all refrigerant work should be logged. So you need to know how much gas refrigerant gas you're putting into a system or taking out. Okay, and we need to indicate these, okay, at all times. You'll notice that there's a scale, very important, vacuum pump, okay, and there's a ventilation fan. Right, so we've also here in our workshop, we've put together an inline tube fan with some flexible ducting on it. And any time that we're working on refrigerant, regardless, that fan will then be taken out, and we will then vent any discharge that we've had from recovery and all that. We will try and vent that away from the work area. Okay, very, very important to remember about ventilation while we're on the topic. Okay, if you're working below ground level or in a basement, regardless of what you are doing, you should ventilate that area all the time, whether you're working with R32 or whether you're working with R22. Okay, these gases take up the oxygen, they push the oxygen out of that area, and it's not good for technicians to be working down there, okay, in an area. So ventilation is incredibly important when working around refrigerants or working in confined spaces below ground level as well. Okay, at all times, for safety, you should keep a powder fire extinguisher in the close vicinity, okay, of the installation. And in actual fact, it's required that one of these should be around your portapack or oxyacetylene kit at all times while you're working. All right, so recovery of R32. Okay, I take it that you guys are all recovering gas and not discharging it. So what's important to know about recovery of refrigerant? Okay, so you will need the following. You'll need a recovery bottle that has a minimum pressure of 48 bar. You will need a scale, leak detector, ventilation, recovery pump, your manifold, and a fire extinguisher. Okay, so these are the items around there. These are the basic tools along with your hand tools that you will need when working. Okay, we're going to cut the power supply to the unit to make sure that the expansion valve on the outdoor unit was open. Important thing to remember that if you turn a unit off from the remote controller, the expansion valve will close, creating two or more circuits in a refrigeration system or air conditioning system. So if you're going to recover refrigerant, you need to allow the unit to be working, and then you cut the power, the expansion valves will remain in the open position so that you can recover the refrigerant. And also important to know that if a refrigerant system has a recovery mode, you need to know how to activate it. That will automatically open the expansion valves, and then you can cut the power to them. Okay, right, refrigerant recovery. So we've discussed the test pressure of 48 bar for the cylinder. Okay, recovery bottles for R32 should not be overfilled. The fill rate is 60%. Okay, and the red shoulder, as they will contain flammable gas. Bottles should be iron, not aluminium, left-hand thread, and remember the logging sheet. Okay, in South Africa, I don't know how you guys operating up in Zambia, but we can go and hire recovery vessels, cylinders from the refrigerant suppliers. Okay, and obviously they rent them out to us, and it's in our interest to get them back as soon as possible, and then they take care of the disposal of the refrigerant. Okay, right. So using recovery vessels, It's never an idea to just keep using the same recovery vessels, because you also might be pulling acids and sludge back, and you don't want that to now contaminate the refrigerants that you're putting in there. Right, so you need a recovery pump. It's always an idea, if you've got a recovery pump, because you're now working with a slightly flammable refrigerant, that you check that your recovery system can take that. So you need to check up with the suppliers and manufacturers, and quite a large number of them on the market are compatible. There are some older ones apparently that aren't. So just an idea before you use them, that you check on their technical specification sheet or from the manufacturer that it's cleared for use with R32. It is advisable to use the recovery pump together with an extractor fan. Okay, we've discussed this. Okay, recover the refrigerant until 0.5 bar absolute pressure, close the stop valves and nuts screwed on. The unit does not contain refrigerant anymore. Recovery bottle returned to supplier. In this case, they've put A gas for reclaiming or destruction. Okay, a lot of recovered refrigerant today is actually reclaimed and put back into the market. Okay, and Daikin's very big on this. We call it a loop. Okay, and basically you'll see on some of our VRV equipment, the VRV4 Plus, a lot of the systems will have a sticker on there saying that they have reclaimed refrigerant in them. And we've commissioned a large number of them, and they work exactly the same as the ones that have new refrigerant. Okay, so we're also moving to the fact that we're trying to reuse refrigerant. What happens, watch points during commissioning, repair, and decommissioning. Okay, these are common work practices. Let's just take the same thing before, 1.2 kgs of R32, full charge of a unit is released, and the solution, you will need 12.6 meters cubed of fresh air, okay, that your extraction fan will need to move. First thing you need to do, ventilate immediately, avoid all flames and hot surfaces, okay. Leave the room until all gases escaped. Okay. Air ingress during pump down, very important. During pump down, never pump down a system into a vacuum. Okay, if there are any leaks on the system, you're going to draw oxygen or air into that refrigerant. And just by doing that, you are now putting yourself at danger, because that air mixed with the refrigerant, if it is enough of it, okay, you could actually cause an explosion inside the aircon unit if it's reused. Okay, so very important. Okay, and so pumping down flare joints can leak under pressure, and the leak will draw air into the system. So please, when pumping down, never pump down into a vacuum. Okay, when commissioning afterwards, the air will mix with the R32 flammable mixture, and ignition will cause an internal explosion. Now, prior to 2020, and before we all went into lockdown, in around 2018-19, there was a total of about 9 big accidents globally, okay, that happened, that were recorded. Now, if an accident's recorded, you can bet that there were a lot more that weren't recorded. Okay, in cases where air conditioning units actually exploded. Okay, and in all of the cases, when investigating, you could find evidence that there was oxygen inside the system. Now, let's just consider. Okay, R32 we've said was slightly flammable, and if there was oxygen in the system, in the presence of a compressor that is increasing the heat, okay, we have the potential for that system to explode. But there's also cases of systems like R32, okay, and 410A that have exploded. And people say, well, how is that possible? And again, we have the diesel effect. If there's enough oxygen inside an air conditioning system, okay, and we have a compressor and heat and oil, okay, we have the potential for an explosion to happen. Okay, one of the particular accidents that took place in Africa, took place in Nigeria. If you look at the photographs from the accident, 2 technicians were killed working on a very small split system. Okay, it's very, very important, guys, and I'm going to put this through. This is not a case that R32 is dangerous. This is a case that the practice that has entered the industry, where guys don't pull vacuums or they air purge, so they just open up the liquid line and they hope to push out all the oxygen through the piping, and then they tighten up the suction line flare. That kind of practice is dangerous. Okay, so we're not just talking about R32 here. We're talking about a practice that needs to disappear and must not be done anymore. Okay, it's a very, very bad habit. Okay, and the explosion leads to a high internal pressure, and the high pressure could lead to rupture, and you get a flame jet out of it. Okay, and shrapnel, and you can have injuries or death from that. Okay, so that's the air ingress during pump down, but air can also ingress during commissioning when guys don't pull a vacuum and they try the air purging method. Okay, oxygen must be avoided at all times in any refrigerant system or circuit, and it's strongly advisable to measure the saturated pressure and temperature when the unit is being pumped down or when there's any doubt that air might have entered the system. And of course, this is a common thing that all apprentices have probably been introduced. They were taken to some cylinders in a workshop, they were unmarked, and they were asked to identify what refrigerant was in there. And the two things they needed to know was the pressure and the temperature of each of those cylinders to identify the refrigerants. But on the other hand, knowing a refrigerant type in a cylinder or in a circuit also enables us to determine, using the pressure temperature, whether there is something else contaminating the system, like air or another gas that has entered into that system. Okay, and I'll say other gases because I've heard some scary stories of guys that have used acetylene to try and pressure test, and that's also an absolute no-no. Okay, and also nitrogen left in the system after guys have been brazing. I take it that everybody brazes with nitrogen. Okay, very, very good practice. Ensures that your pipes are clean. Right, so what happens if the incorrect refrigerant is used? Okay, and this is important to know because we often come across this in the industry as well. So if R32 unit was charged with R22, the chlorine content in the R22 damages the refrigerant oil. Okay, there's chlorine in R22, and the degradation of the refrigerant, the oil reduces lubrication and can cause compressor to become damaged. Okay, so it can cause mechanical damage of the compressor. If R22 unit was charged with R32, remember R32 operates at a much higher pressure, about 60% higher than R22. Therefore, in terms of the pressure resistance of the machine, incorrect refrigerant charge can cause a very dangerous situation. In addition, the lack of compatibility between R32 and mineral oil is also a problem and reduces the oil return performance. And on top of R32, the oil separating into two layers inside the compressor, hindering the proper oil supply to the bearings. So it can also cause mechanical damage, okay, to the compressor. Okay, what happens if the incorrect refrigerant was used between R32 and 410A? This was one of the very first questions that people started to ask us. If R32 is in R410A and the two have very, very similar pressure temperature characteristics, why can't you just charge R32 into a 410A system? Okay, some good reasons that you need to know why it cannot be done. Okay, so R32 units and R410A units are optimized to their respective refrigerant properties. Okay, so therefore charging them with an unintended refrigerant prevents proper operation. Remember, we said that R32 has a much higher refrigerant ability, a refrigerating ability. So it does tend to go in hand, that the units are slightly smaller. Okay, and also due to the additional heat buildup in R32 compressors, the clearance tolerances of those compressors are larger than those of 410A. Okay, so clearance, that's the clearance between the scrolls, okay, or if it's a rotary compressor in the rotors, okay, and that clearance is very important for enabling the compressor to run efficiently. So if they start to overheat, we can cause big problems inside the compressor. Therefore, charging R32 into a 410A system can cause mechanical binding of the compressor moving parts and lead to compressor failure. So it's not recommended. The two gases are not interchangeable in the systems. Okay, so please take note of that. Okay, the watch points again. Danger of R32 and other refrigerant trapped inside refrigerant piping during repair. R32 can be locked up in a system even after evacuation, okay, and recovery. It's always verified if the refrigerant might be trapped inside there. Okay, so it's not advisable to start approaching any refrigeration system with a flame to unsweat pipes, okay, if you have not confirmed that there's no refrigerant inside those pipes. And again, a couple of years back, right here in Cape Town, out in the Pole area, a technician was killed doing a compressor change because there was gas still trapped inside the piping. And when he unsweated that, the oil ignited back onto him and actually set his overalls alight, and he was actually burnt to death. Okay, so a very, very important thing to remember, and hopefully something that you've never had to experience. Okay, all right. So the danger of R32 or any other refrigerant trapped inside the refrigerant circuit during repair must be considered. So recover the refrigerant to verify the recovered quantity, flush with nitrogen gas for brazing, and check if the flow comes through. Okay, always cut out the parts to be repaired. It's always a good thing if you're going to do a compressor replacement, provided you take care not to drop filings into the piping, to cut out the compressor. Okay, so the filings fall back towards the compressor because you're not going to be using it again. And if cutting out the parts is impossible, then puncture the pipe to ensure that there's no refrigerant in there before you unsweat it. Okay. All right, so in closing off the presentation, and before we go into some questions and answers, let's just quickly run through a couple of things here. Transporting in a van, okay. Concentration of R32 is a safety problem. What do you need to do? Ventilation. Is this different to how you've worked in the past? No, it shouldn't be. Okay, it should be the same. Emission during vacuuming, the concentration of R32, there's no risk. It's the same. Okay. Emission during disconnecting an R32 pressure gauge hose, concentration again is R32. As long as you're ventilating, okay, which you should have been doing, then there's no risk. It's the same. Emission during disconnecting, and disconnecting hoses, okay, same thing. Full accidental release, in other words, all the refrigerant escapes immediately. What should you be doing? You should be ventilating, okay, and it's exactly the same procedure. So there's no new procedures that should be coming into this. These should all be habits that a good technician is following all the time, okay. Air ingress during pump down procedure, you have a flammable mixture of R32 and oxygen. Avoid, check manifold, that was the pressure temperature check, okay. Again, is there anything different about it? In the past, again, you should have always been checking those type of things. Pressure temperature to tell you whether your refrigerant is contaminated or not. R32 blocked inside a refrigerant circuit during repair, okay. And again, as we said, if flush with nitrogen, check for flow, cut out the parts, or puncture the pipe to make sure that there's no refrigerant left inside the system. The tooling for R32 is similar to tooling for all other refrigerants, but always check your documentation, okay, that it's compatible. As we said, recovery units, it's a good idea to check with the manufacturer whether they're suitable for R32. Like I said, most of the newer ones are. There's a couple of older ones that aren't on the market. Your manifold is the same, provided that you have the temperature pressure scale in your gauges for R32, okay. Leak detectors you need to check as well as to whether they can pick up R32. I'm still a soap and bubbles guy. I still maintain it works for all refrigerants, and I think most of the guys I come across still keep soap and water in their vans. Okay, the gas adapter is a left-hand thread. You will need an adapter to bring that out to a right-hand thread flare connection, which we are all used to using. Okay. Installation procedures for R32 unit are exactly the same as for R410. Okay, and in saying that, just to remind you, the things that we need to do, we need to keep the system free of moisture, okay, free of air, clean and tight. Okay, so we don't want leaks. We don't want contamination. Okay, so we need to make sure that those things are adhered to in any installation process that we take. Okay. Tools need to be rated for use with R32, so you just need to make sure that what you're using, and generally if they could take the pressures of 410A, they will take the pressure of R32. Safety requirements for ventilation and recovery cylinders are different. Remember, we spoke and we said that R410A is a 40 bar right-hand thread, and for the recovery bottle, and in the case of R32, it's 48 bar left-hand thread. Okay, so that chart over there is confirm the rate for the use. The standard refrigerant scales are very, very important. And again, please use a refrigerant scale, not the types that you pick up from your local supermarkets and pharmacies. Those scales lie. You can ask anybody who's been dieting. Okay, you must use a highly calibrated, highly accurate refrigerant scale when weighing or recovering refrigerant. Okay, leak detectors confirmed that they can be used with R32. The same for recovery units. Ventilation is recommended at all times. Okay, that you are working with any refrigerant. Okay, all right, gentlemen, that is the end of the discussion. Okay, and what I'm now going to do, let me just close that down over there. Okay, right, everybody's still with me. Okay. What we're going to do now is we're going to enter into a time where you guys can ask questions. So I think the idea was each of your training centers has got a coordinator, and that coordinator, I think, is going to transfer the question through to me. Okay, and then I'm going to discuss that question with you guys, and yeah, and then we can carry on. All right, so are there any questions?
Glenn, can I just step in here as well?
Okay.
Just to all the Drake and Gordon staff, please ask questions. Don't be shy.
Yeah.
If you need anything, ask now while you can.
Yeah, guys, please. You guys are here on a Saturday, so let's make the most of this time. Okay. I'm recording the question and answer session as well.
Glenn, can you hear me?
Yes, I can hear you.
Okay, this is Melvin from Indola office. I want to find out whether on the installation, is it aluminum pipe recommendable to use for as copper pipe for R32 unit?
Okay, all right. Again, Daikin do not recommend aluminium piping, okay, because of some of the problems that have happened. But we do have people that are using the aluminium pipes, and if you do use it and it ruptures, it's at your own expense, okay, in terms of that. So with a refrigerant that is slightly flammable, I would recommend staying away from aluminium piping. It's notorious for rupturing, and I was in contracting, and I had a lot of experience with trying to use aluminium, and we went back to copper. I do not think it's a refrigerant piping suitable for use with slightly flammable refrigerants. I know the market's driving us down.
Another question, how about R22 pipes? Like if you still have some R22 pipes in stock and they want to use it, is it possible to use it for R32?
Okay, again, R32 pipes must have the same wall thickness as for 410. Okay, so remember 410 was supposed to be thicker piping. All right. For me, I would say that you need to pressure test the piping. If it's very old, I would recommend replacing it. Okay.
Thank you. We just want to make
any more questions?
Sir, can I have a question?
Yes. Okay.
Our maintenance manager asking if we will, for the vacuum pump, do we need to use ordinary vacuum pump or a special vacuum pump for R32 because of explosion? Or?
Yeah, all right. Okay, remember that the vacuum pump you're only using after the R32 is removed from the system, so you do not need a special vacuum pump. Okay, you can use the same pumps that you've been using. Just remember with vacuuming that you replace your vacuum oil, okay, at least after every 8 hours of operation. Okay. Did you get that?
Okay, sir. Thanks. Thanks.
Yeah, sure. Okay.
In case of compressor damage, how can we change the compressor because we cannot pump down the system? And the saying is high frequency. How much oxygen do you need?
Very slightly. Glenn,
Yes.
there's a question here. It's Lindsay. The gentleman wants to know that if the compressor is damaged, is it dangerous to pump down the system and remove the compressor?
Okay. Right. First of all, if we consider a compressor damaged, I'm taking it that the compressor has lost efficiency. It's still capable of pumping. Okay.
Yeah.
Am I right? Okay.
Yeah.
So if a compressor's lost efficiency, you'll never be able to pump it down. So what you would need to do in that instance is you need to recover the gas, the refrigerant from the system using a recovery machine, and then you take the compressor out. Okay. You can only pump down a system.
Hey, Glenn.
Hi,
Yeah, Jeremiah here.
hi,
Yeah,
Jeremiah.
in case the compressor is damaged because you cannot recover it using the pump down system. So how can we pull out like the gas as you have stated?
Okay. All right. So what you'd use is you use a recovery machine, a refrigerant recovery machine. Are you guys familiar with that? Okay. It's a machine that you couple up to the system, and it actually takes the gas out of the system. Okay. So you're not using the compressor of your air conditioner. You're actually using another system with its own compressor, and it recovers the gas out of the system.
Okay.
All right.
Then well, Glenn, can you hear me?
Okay, I can hear you. Go ahead.
Yes, I've got two questions.
Okay, go ahead.
We have a question regarding how to fill up the R32 to the unit. Normally, the R410, we have to put it liquid, right? Now, on the R32, how should be the filling up?
Sorry, you're breaking up there, Melvin.
Yep.
Sorry, you got a bad signal there. Could you just repeat that question? Can I mute, Melvin? Let me just mute the guys. Okay, right. Okay, so it's just you and I. Melvin, could you give me that question again, please?
The question of our team here, Mr. Danny, is how to top up R32 on the system. Is there a required procedure to top up R32 on a system?
Okay, all right. So topping up of refrigerant, yes. Okay, remember that you couldn't top up with R410 because it was a blend refrigerant, and when it leaked, you never knew what composition of refrigerant you had. R32 is a single blend. Yes, you can top up. Okay. Again, anytime that you're topping up a refrigerant on a system with refrigerant, you need to be monitoring your on-coil, off-coil temperatures, your gas, and your pipe temperatures. It's very difficult to do with inverter units because you never quite know where the compressor is. So the recommended practice, okay, when working with inverter systems is to recover the refrigerant and weigh it and compare it to the actual factory charge and what's required. And if it's under, you put it in and then you weigh in the difference. Okay. So that's the one thing that makes working with inverters a challenge, is that they're difficult to charge because as the RPM of the compressor decreases, so the pressures start to come together like in any unloaded refrigeration plant. So it's very difficult to top up. An experienced technician can top up a system, all right, if he's able to correlate pressures and temperatures together. But its recommended practice is to recover the refrigerant, weigh it, then where you can use it back into the system and weigh in the difference that's missing. But also consider this: any time that you've lost refrigerant in a system, okay, your first mode of repairing is to find out where the leak is. All right. Okay, does that answer your question?
One question that they have is, do we need by gas or by liquid? Can we do gas tapping or liquid tapping?
Or liquid. Okay. R32, you can charge in as gas or liquid.
Okay then. All right.
Okay. That's all right. Very, very good question, actually, to know. Okay. All right. There was a gentleman in the red shirt who was going to ask me a question. Okay. Do you want to just turn your microphone on? Yeah, there we go. All right. Okay. Thanks.
Earlier on, you said R32 is a single component. And then there was a question that was asked to say, what if you use R32 without R125? So what is the relationship between R32 and R125?
Okay, so what is the relationship? Okay, so in 410A, we have 50% R32 and 50% 125A. 125, sorry, 25. 125 is the fire retardant. Okay, it was added to the R32 to make 410 in order to stop the 410A to be from burning. That was the only reason it was added. It's got a very, very low refrigerant ability. Okay, but as a global warming thing, gas, it's very, very high, and that's why it's been taken out. Okay, so does that answer your question? The relationship between the two is that one was added as a fire retardant.
So is it a mixture of the two, or R32 still remains a single component?
Okay, so in R32 is on its own. It's a refrigerant on its own. There's no other refrigerant added to it. Okay.
Okay. Okay. So in this case, now concerning recharging, so how do we recharge R32? Is it like the way we do with R14, like turning down the cylinder, or just put it straight like that?
You can charge it both as a liquid and as a vapor.
Okay.
That's the pressure. That's the pressure. What is the normal pressure? Operating pressure. Pressure. That's the pressure, so we know when we do the installation.
How are you, sir?
No.
How are you, sir?
I'm fine, thanks.
Yeah, I want to find out the relationship between the 410 and the R32 in terms of suction pressure. What's the difference?
They are very, very close together, probably around about 7 bar. Okay, so remember I showed you the graph, and we had the pressure temperature relationships on that graph. You saw that those two lines were very, very close together. The only place where they go out very slightly is in the condenser. So your condensing pressure will be slightly higher than 410A. R32 will be slightly higher than 410A in the condenser, but in the evaporator, they are very, very close. You're looking at about 7 bar. On a system operating, member pressure, air conditioning is pressure temperature related. So that question is a bit of a blanket one, because if you've got a very high on coil, you can expect a higher temperature and pressure. Okay.
Anyone else?
Okay. Any more questions there?
Glenn, the guys are also asking, what is the operating suction pressure and high pressure of the system of R32?
Sorry, just this, I don't know your area. Just repeat the question, Melvin.
The operating suction pressure and high pressure of the R32 air conditioning unit. Operating suction pressure.
Operating suction pressure. Okay, so there's a question I was talking to the guy now. You can expect the suction pressure on a system operating when it's reaching temperature of around 7 bar. Okay, very almost identical to 410A. Okay, the discharge pressure would be slightly higher than 410A. Okay, which is in the region of about 2,200, depending on what your ambient conditions are like. Okay, so it's very close to 410A in its operating temperatures. Where there is a difference is if you measure discharge temperature on the pipe on the compressor, the discharge temperature tends to be elevated. It's quite considerably higher than 410A. Okay. So do you understand what I'm saying when I talk about discharge temperature? Okay. All right. Great.
Glenn, another question on this side.
No,
I have
go
another
ahead.
question.
Hello.
Hi.
Yeah, my question is that what is the kg for 32 cylinder and what's the coat color?
Okay, the refrigerant cylinders come in different kgs. Okay, we've got some small service cylinders that are in the 10 kg range. Okay, and the code color is a gray cylinder with a red shoulder for a standard cylinder. Okay, so it's gray with a red shoulder.
Thanks, Glenn.
Okay, just remember on that as well while we're talking about cylinders, remember it's a left-hand thread. Okay. Yeah.
Hi, Glenn. Another question from our side. Hello?
Hello, I'm here.
Yeah. Does R32 specific smell? Like if you have a leak on the and you do not know and you just came into the, does it have a specific smell like the hydrocarbon smell made? Now, does the R32 have the same specific smell for it?
The odor is almost identical. Is identical to 410A.
410A.
Yeah, so it's Okay.
Then. Thank you.
All right.
Hi.
Hi.
How are you? This is
I'm well, thanks.
Okay, good. We know that R32 is efficiently heat pump based. Any reduction in electricity consumption, because we need also to share this one to our client.
Yes, there is a reduction in electricity consumption, and that you can pick up off of the specification sheets for the equipment that you're installing. That's one of the reasons why they've changed over. Okay.
Okay, thank you.
Right, sure.
Hello, sir. I have a question.
Yes,
so,
go ahead.
Yeah, aside from global advantage on global warming potential for R32, based on your experience, what is the EER comparison from R410 and R32, same capacity?
Look, I haven't got that information on me, but it is less. What we could do is we can get the documentation together for you, and we can actually get it shipped. We can get it out to you. So, Johanna, if you're still with us, you could just take note of that. If we could put a documentation package together. I haven't got it with me for this course. Okay, but it is less.
Okay, sir. Meaning based on energy consumption is higher?
It'll be lower.
It will be lower, sir. Okay.
It will be lower, yes. Okay. Any more questions? Okay.
Nothing here, Glenn.
Nothing here. Okay, should we call it a morning?
Nothing here.
Okay, I'm going to stop.
Glenn, one more question.
Okay, one more question. Okay, hang on there.
Sorry, I forgot to to acid. How about the product of decomposition?
Sorry, the
product of decomposition.
Yes, okay. What would you like to know about it?
So for decomposition on this product, how can
R32, the composition, it's a pure refrigerant. So R32 is a refrigerant like working with R22. There's no, it's a pure refrigerant. It's not like 410 where you had two refrigerants added together. Okay, or what they call a blend. Okay, so R32 is a pure refrigerant. That's why you can charge it as vapor and liquid.
Okay, thank you.
Okay, all right. Okay.
All right, Glenn, that's it.
Okay, all right. Okay, I'm going to stop the recording here. Gentlemen, thank you very much for your time this morning. Okay, and I hope you enjoy the rest of your weekend. And yeah, and then we'll stop there.